One.
Hello everyone, my name is Ayushi Kamle and I am going to explain you about the GSM system architecture. Now firstly I will discuss what is GSM. GSM stands for Global System for Mobile Communication that represents today's most successful digital mobile telecommunication system. It is used by over 100 million people in more than 130 countries worldwide. That is 80% of the world uses GSM technology while placing wireless calls. The primary goal of GSM was to provide a mobile phone system that allows roaming of users through Europe and other parts of the world. In simple word, we can say that GSM is a wireless transmission standard for digital cell phones used worldwide. From the name, we can say that it is used globally for the communication purpose. GSM originally stood for Group Mobile, but now it is named as Global System for Mobile Communication. GSM uses a variation of time division multiple access and is the most widely used for three digital wireless telephony technologies, that is TDMA, GSM, and CDMA. Now, what is TDMA and CDMA? Both are the digital wireless technology that is in TDMA. It allocates each user a different time slot on a given frequency, but in CDMA, it uses spread spectrum technique. That is, instead of given frequency to each user, it assign every channel uses full available spectrum. Now, what is the system architecture? As with all system in the telecommunication area, GSM comes with a hierarchical complex system architecture comprising many entities, interfaces, and acronyms. It consists of three subsystems, that is a radio subsystem, networks and switching subsystem, and the operation subsystem. I would explain further all these. Now have a look at the architecture of the GSM. Now it has three slots, that is RSS, NSS, and OSS. These three has comprises of several entities, interfaces, switches, and databases. Now firstly I would explain RSS. RSS stands for Radio Subsystem. It comprises all the radio specific entities, that is the mobile station and the base station subsystem. You can see in the figure that the connection between the RSS and NSS is done by the A interface, and the connection between the NSS and OSS is done between the O interface. Now, what is A interface and O interface? A interface typically based on the circuit switch system carrying up to 3064 kbits per second, and O interface uses signaling system carrying management data to the RSS. Now, first we will start with base station subsystem. BSS, that is BSS, a GSM network comprises many BSS, each controlled by a base station controller. The BSS perform all functions necessary to maintain radio station to an MS, coding, decoding of voice, and the rate adaptation to the wireless network part. Besides a BSS, the BSC, the BSS contains several BTSs. You can see in the figure that there are several BSS present in RSS, and it comprises of a single BSC. And now apart from the BSC, it has several BTSs also. Now, what is BTS? That is base transceiver station. A BTS comprises all radio equipment, that is antennas, signal processing amplifiers necessary for the radio transmission. A BTS can form a radio cell or using sectorized antennas several cells, and is connected to MS via the interface and to the BSC via A-base interface. You can see here a BTS has a radio cell like this here, and connection between the BTS and MS is done by the interface, and between BSC and BTS it is done by the A-base interface. Now A-base interface is of 16 or 64 kbits per second connection, and interface contains all the mechanism necessary for wireless transmission. Now next is base station controller, that is BSC. The BSC basically manages the BTS. It reserves all radio frequencies, handles the handover from one BTS to another within the single BSS, and perform paging to the of the MS. Now the BSC also multiplexes the radio channels onto the fixed network connection to the A interface. Now it basically manages the all the BTSs that is present in the single BSS, and perform all the functions like paging to the MS, handles the handovers from one BTS to another, and etc. Now what is MS here? MS is next is MS, that is mobile station. The MS comprises all user equipment and software needed for communication with a GSM network. An MS consists of user independent hardware and software, and of subscriber identity module, that is SIM, that we use every day in our life, that which stores all the user specific data that is relevant to the GSM. While an MS can be identified via the International Mobile Equipment Identity IMEI, and a user personalize any MS using his or her SIM. Now here SIM contains many identifiers and tables such as card type, serial number, a list of subscribed devices, that is a PIN number, PUK, authentication number, authentication key, and IMSI number. Now the next is network and switching subsystem. Uh, Here it is said that the heart of the GSM is formed by the network and switching subsystem. NSS connects the wireless network with standard public network, performs the handover different BSS, that is it handle the and manages the different connections between several BSS, and it comprises functions for worldwide localization of users, and support the charging, accounting, and roaming that of users between different providers in different countries. It consists of several switches and databases. The first one is Mobile Services Switching Center, that is MSC. MSCs are highly performance digital ISDN switches. They set up connection to other MSCs and to the BSS via A interface, and to form the fixed backbone network of a GSM network. A gateway MSC has additional connection to other fixed network such as PSCN and ISDN using additional internetworking functions. And MSC can also connect to public data networks. Um, and MSC also performs all functions needed for supplementary devices such as call forwarding, multi-parting calls, reverse charging, etc. MSC manages several BSCs. MSC handles all signaling needed for the connection setup, connection release, and handover of the connection to the other MSCs. The main example for this is the SS7, that is signaling system number 7. It is used for this, and it covers all the aspects of controlling signal of digital networks. Now the next is home location register, that is HLR. The HLR is the most important database in the GSM system, as it stores all the user relevant information. That is it from the name it is understood that home location register, where all the informations of the users is stored. This comprises static information as well as dynamic information. In static information, it has mobile subscriber ISDN number, subscribed devices, and international mobile subscriber identity. In dynamic information, it has current location area, that is the location area of the user, or we can say that of the MS, that is mobile station, that is used by the user. The mobile subscriber roaming number, the current VLR, and MSC. HLR manages data for several million customers and contain highly specialized databases which must fulfill certain real-time requirements to answer requests within certain time bounds. In HLR, as the MS, that is mobile station, leaves the location area, the information in HLR is updated, and this information is necessary to localize a user in the worldwide GSM network. Now the next one is visitor location register, that is VLR. The VLR associated to each MSC is a dynamic database which stores all important information needed for the MS users currently in the location that is associated to the MSC. If a new MS comes into a location area, the VLR is responsible for that, and it copies all the relevant information for this user from the HLR. This hierarchy of VLR and HLR avoids frequent HLR updates and long distance signaling of user information. As in visitor location register, if a MS, that is mobile station, changes its location area, then all the information of the users from the HLR, it is transferred to the VLR, that is visitor location register, and it copies all the information from of the user from the. Now the next is operation subsystem. In operation first system, the first entity is the operation and maintenance center, that is OMC. OMC monitors and controls all the other networks entities via the O interface. That is whatever the entities that is connected via the O interface above the OSS, that is of the NSS and RSS, that all are monitored by the OMC and controlled by this only. Typical OMC management functions are traffic monitoring, status report of network entities, subscriber and security management, or accounting and billing. OMC uses the concept of telecommunication management network. The next one is authentication center, AUC. The AUC contains the algorithms for authentication as well as the keys for encryption and generates the values needed for user authentication in the HLR. As the radio interface and mobile stations are particularly vulnerable, a separate AOC has been defined to protect user identity and data transmission. The AOC is situated especially in the protected part of the HLR. The next one is Equipment Identity Register, that is EIR. The EIR is a database for all IMEIs, that is, it stores all device identifications registered for this user. As mobile station are mobile only, so they can be easily stolen. So with the valid SIM, we anyone could use the stolen MS, as the EIR has a blacklist of stolen devices. So unfortunately, the blacklist of different providers are not usually synchronized, and the illegal use of a device in another operator's network is possible. In theory, an MS is useless as soon as the owner has reported a theft for that. The EIR also contains a list of valid EMIs, that is whitelist, and a list of malfunctioning devices, that is graylist. So that's all for the GSM system architecture. Thank you.